We're going to outline the procedure for creating frequency tables that span data. The first step is to identify the maximum and minimum values for any data set. For this example, I'm just going to make up numbers. As I look at my hypothetical data set, I find that I have a maximum value of 343. I also find the minimum value, the smallest value of the data set, and I find that to be 122. Once you've identified your max and minimum values, you want to determine your range. That's step 2. Range is found by taking max minus min. Max minus min. For this example, we would take 343 and subtract 122. That would give us a range of 221. From here, we have to designate an appropriate number of classes. In most statistical examples, your teacher will provide you with the number of classes. As a general rule, you want to choose somewhere between 5 and 25 classes. The idea is that you want to identify the major trend in the data. And so in this example, we're going to say that we need 7 classes. Again, it's usually stated in the problem, but if it's not, if it's like a project you're doing or something like that, you want to choose somewhere between 5 and 25 so that you can identify the major trend of your data. For step 4, we want to calculate the class width. To calculate class width, you take the range and you divide by the number of classes. In this example, we take the 221 and we divide by 7. 221 divided by 7 produces a result of 31.5714, and the decimal goes on. So I'm going to say roughly 57. What you have to remember when you're calculating class width is that there's an extension of this calculation. You have to round up. And since our original data was recorded as whole numbers, we want to round up at least to the next whole number. In this example, I could round up to 32. That would be an appropriate level to round to. However, when I teach statistics, I allow kids to go a little bit further. And so what I'm going to do, I'm going to round up to a nice number like 35. And when you do this, you have to be careful not to round too far. I think it would be okay to round up to 35 for this example. And I want to span my data. And what that leads us to is something called tolerance. We'll create a freak table, we'll create a histogram that goes just a little bit further than the actual data. So we'll be able to trim off the upper end and the lower end of our data. We'll have a little extra room to play with, is what I'm trying to say. And so we call that tolerance. How tolerance is calculated, you want to take your actual value and subtract that from the rounded value. I'm going to have to scoot this over here just a little bit. Rounded. In this example, I could take 35 and subtract the 31.57. When I do that, I get 3.43. That 3.43 is how much tolerance will be created in each of the classes. And so I'm going to multiply by the number of classes and get a result of 24.01. And then what you always do, you have to subtract the unit of measure. And so I'm going to subtract 1 unit of measure. Because we're measuring in whole numbers, I'm going to subtract 1. And so that gives me about 23 units to play with. That's my tolerance. And that will allow me to go back to my original data and figure a nice point to start at. My minimum value was 122, but I had a tolerance of 23. I like to cut that about in half and find a nice starting point. So cutting 23 in half, we would say that's going to be 11 and a half. So somewhere in the 11 and a half range. But I need to start so that I get whole numbers. And so if I take this back, let's go 12. If I go back 12 units, I could start at 110. And so when I'm talking about starting with 110, I'm talking about creating a freak table. So I have this little worksheet ready. I would start at 110, lower class limit. Remember, limits have to match your raw data. And then because we were going to count by 35, that means I can add 35 each time. And so in my calculator, I'm going to start with 110. I like to hit enter, and then if I hit plus, you see how the A and S comes up on the calculator? When I add the 35, which is my class width, it'll automatically add the 35, and I don't have to keep retyping it into the calculator. So when I hit enter, it takes me to my 145. If I were to hit enter again, see, it takes me to the 180, and I can run through this whole process. So I've got my 180. Remember, I only have 7 classes, so I hit enter, I get 215, hit enter, 250, that's 5 classes so far, 285, that's 6 classes, and 320, so I end at 320. Now, to do the upper class limits, we're breaking our data into these subgroups, into these classes. If this first class starts at 110, I need to find a stopping point that stops just before the second class begins at 145. So the natural count there would be 144. I want this to stop at 144 because we're counting in whole numbers. The next one would be 179, so on and so forth. And this can occur just by taking in the calculator again. If you go 144, and then you can hit enter there. So now when I say plus, I add that 35, the class width, and it'll count through there again. So I got my 179. And notice as I hit enter, it's just going to give me all these units. That's just one less than the lower class limit. So I go 214, 249, 284, 319, and we end at 354. Now, the idea of spanning the data comes from when I look at the max and min value. So we notice that the 122 falls in this first class. In a similar way, we can't end with an empty class. And so when we see 343, we come all the way down here and we ask the question, does 343 fall between 320 and 354? And of course, it does. And so we know that we've spanned our data set.